production process of carbon fiber starts with the production of a so-called polyacrylonitrile precursor. In our case, this precursor is produced in Otake, Japan. From there, it is being shipped to Seattle. From Seattle, it is then trucked to Moses Lake, to our Moses Lake plant, where we convert the polyacrylonitrile precursor into a carbon fiber. The carbon fiber consists of 50,000 individual filaments in one strand and is wound on spools. These spools then are shipped to Germany, to Wackersdorf, to the plant in which we are standing right now. Here we produce non-trimmed fabrics from these carbon fibers coming from Moses Lake, and then these non-trimmed fabrics are shipped to BMW Landshut in Leipzig.
This is the krill area of the process. Each of the bundles, the precursor bundles, are routed up through the krill and then uniformly into a web and then entered into the next area of the process. This is the oxidation portion of the process. This process oxidizes and stabilizes the material in preparation for carbonization. As the material is heated, the material changes color as the oxidation level increases. This is the second stage of oxidation. As you can see, the color changes as the oxidation level increases. This is fully oxidized black carbon fiber. This material is now prepared to go through the carbonization portion of the process. This is the low temperature and high temperature portion of the process. Once the material exits the high temp furnace, the carbonization is complete, followed by surface treatment in which the material is etched, which will improve the bonding for further use in a resin system and to build a composite part. Next is the sizing area, where the material is coated with a epoxy sizing to protect the material until it is wound. This is the final process in carbon fiber production, winding. And this is the final product we'll send to Germany.
Here we use a material from Moses Lake. These bobbins are on the creel, and we pull them down from the spools over these mountains here, right to the machine. After the spreading process, here you see the complete carbon fibers in the whole width of the machine. The next step is we bring the carbon fibers down to the stitching process. This part of the machine is the stitching area. We are fixing here the material, the carbon fibers, to hold them in the right position for the next process step. This is the binding process. Now we have reached the last step of the production process of carbon fibers fabrics. Here we are winding up 50-meter rolls, which we ship down to Landshut on this device here. You see the surface of the fabric, and here on this surface the white dotted pulver, which is a binder to fix this fabric.
Well, the benefits of carbon are that it's a very light material. It has a weight advantage of over 50% versus steel and still over 30% compared with aluminum. At the same time, the material is very stiff and it has great characteristics also in the case of a crash, great absorption of energy. And we all know from Formula One races that with these horrific crashes at 200, 250 kilometers per hour, it's amazing to see that the drivers still walk away from these accidents. That's only possible with this fantastic material, carbon fiber. Well, it was really a precondition that followed from our premises in Project I, in that we said we wanted to really change the production of the vehicle and the entire value chain to lower the CO2 footprint as much as possible. And as we knew that carbon fiber manufacturing is energy intensive, we said from the start that we wanted to reduce that carbon footprint as much as possible. And so from the start, we looked at hydroelectric power, and we looked at locations where that was accessible, and therefore we ended up with Moses Lake, because in Moses Lake we managed to also fulfill all the other conditions. We had available land, we had enough qualified labor, and very importantly for our business case as well, we had very competitive rates for the electric energy.